This is your practice quiz video for Focus 4's quiz. On number 1, it says graph, identify the transformation from the parent function and identify the key characteristics. So let's take a look at the graph. So I'm going to type it into Desmos over here on the right. So let's do y equals, and then go to the functions button and go to miscellaneous, which I've already chosen over there on the right. Then hit the log with the little a as the base so that you'll be able to type in the base of 3. Then go to the parentheses, type x minus 2, close parentheses, and add the 1. So that way you get the right graph. I'm going to hit the home button to bring it back to a normal screen and then get some points so I can graph it. So that first point they had was the x-intercept, so that can already answer one of these questions I have. So let's write down the x-intercept is 2.3330, and then we're going to put it on the graph, so about right there. Then the y-intercept, if you notice, the graph goes down and drops, so it has a vertical asymptote at x equals 2, so it's never going to touch the y-axis, so this one has no y-intercept, and the asymptote is x equals 2, but we just need some more points to put it on the graph, so let's grab a few more points off of Desmos. Let's see, it looks like 5, 2 would be another good point, so 1, 2, 3, 4, 5, 2. And then I can draw it so it looks like it never goes past x equals 2 right there, because that's the vertical asymptote. So domain is how far the graph goes from left to right. So it doesn't go any further past x equals 2. So we would say it's from 2 but not equal to 2. Then it goes to the right forever, so that would be to infinity. The range for this graph, since it goes down forever and up forever, would be all real numbers or negative infinity to infinity. And remember, you'll only be asked for 2 of these characteristics on the quiz, not all of them, but I just like to review all of them so that you get to see them again. And then the transformations, we would say this went to the right 2 because of the minus 2 in parentheses, which is our grouping symbol, and then it went up 1 because our k was equal to 1. So because of that positive 1, it went up 1. And that was it for number 1. Let's look at number 2. So number 2 deals with properties of logs. So even though there are parentheses on this problem, you can actually rewrite it without parentheses and it means the same thing. So if they look confusing to you, I would just rewrite it without them. And then I would move the coefficients first, because we're condensing, and make those as exponents. So log base a of x plus log base a of y squared minus log base a of z to the 5th. And then put it all together. So remember what we talked about in class, that if it is added, it goes in the numerator. So first, write down that first statement you have of log base a of x, but then you're adding y squared, so that goes in the numerator, and then you are subtracting z to the 5th, so put that in the denominator. And that's it for number 2. Number 3 says solve log base 5 of 14 equals x. So there's a couple ways we could do this. We can either type it in Desmos or in the graphing calculator, but you just want to type it in because there's nothing you have to rewrite or actually solve for. It's kind of just a calculator problem. So on Desmos, I'm going to hit functions again and click miscellaneous and log with the little a as the base, so I could type in the base of 5. Then move over to the parentheses and put in the 14. And then right there in the corner is the answer. So 1.639, let's say 1.64. And then I can show you with the calculator. So let me grab my calculator. So just on your regular screen, you can either type math and go to log base if you have a newer model calculator. And you have a base of 5, and then you have 14 in the parentheses, and you get the same thing we got with Desmos. If you have an older calculator, you have to do what we call change of base. I'll write it over here. So change of base works on any calculator, and you just have to type in log of what you're taking the log of, which is 14, and then divide by a log of that little base. Since it's not 10, we have to do it this way. We can't just type it directly into our calculator. So log of 14 divided by log of 5. Notice they all give us the same answer. All right, so let's look at number 4. We have e to the x minus 3 power plus 4 equals 15. So the first thing I would do is subtract the 4 to get the e to the x minus 3 power. It's like the exponential part by itself. And that would equal, not 19, 11. Let me make that look a little better. Okay, and then you could take natural log and rewrite it. So let me start from natural log base e of 11 is equal to x minus 3. We just have to use natural log because that's the only type of log that has a base of e. And then you can type natural log of 11 directly in the calculator. Since it already has a base of e in your calculator, you don't need to do anything extra to type that in. And then you have 2.397, or let's say 98. It'll round up to 8. Equals x minus 3. And then we can add 3 to both sides. So you get 5.398 equals x. Now the other way to do it is I would use Desmos to type this in and find where they intersect. So let's take what's on the left. So put a lowercase e. You want to put in an exponent with parentheses to group the x minus 3 all in your exponent. Then move it down to put the plus 4. And then in the second equation, put y equals 15. And then you just have to find where they touch. So notice we still get 5.398 with Desmos. So I'm just going to write out what I did in Desmos over here. So in Desmos, you would put y equals e to the x minus 3 power in parentheses plus 4. And you don't have to put the y equals. You notice like it worked on mine without that. But just if you're in the habit of always putting y equals, it works as well. So I can like go over here and show you. If I add y equals, it gives me the same thing. Okay, so then let's type or write one more thing. Find where they touch, and then you just want the x value. You're only interested in that one value of the point where they touch. All right, the last problem for your quiz would look similar to this one. You invest $5,600 into an account earning continuously compounded interest. If you want to have $8,700 in the account after 7 years, what interest rate does the bank need to offer you? So, continuously compounded interest tells us that we need the PERT formula. So A equals P e to the RT power. A is your final amount. What's always on the left side is our final amount, no matter what letter they use. P is the initial amount. Again, no matter what letter is there, that would always be our initial amount. And then R equals the rate, and T is time. All right, so let's fill in what we know. We know we want to get $8,700 eventually, so that's our final amount. $5,600 was our initial amount. We're looking for the rate, so let's just put the E, and then 7 years is time, so I'm going to put 7R for the exponent. And then we can solve it. I'm going to solve it 2 different ways. So I'm going to solve it by hand, and then I'm going to show you how to do it in the calculator. So by hand, we could divide by 5,600 first to get the exponential expression by itself, that little e. So I'm just going to use Desmos for a calculator. over here on the right since I already have it open. So 8,700 divided by 5,600 gives me, let's say 1.55. 1.55 equals e to the 7r power. So then if we use our little cloud to rewrite this expression in log form, we would have e natural log base e of 1.55 equals 7r. And it might help to see it better if you put the 1.55 on that side. So then you can see how the little cloud would fit our equation. So natural log base e of 1.55 equals 7r. And then you can type in, I think it works in Desmos to type it in. Let's just try. Natural log 1.55 is 0.438 equals 7r. And then we just have to divide by 7. So let's put 0.438 divided by 7. And we get that r would equal 0.063 or 6.3% would be a really good way to write the rate. Okay, so let me show you how to do this straight into Desmos instead of solving by hand. So if we take that original setup we wrote down, so I'm just going to write it over here again so you can see it better. 8,700 was equal to 5,600 e to the 7r power. So let's put in y equals 8,700. And then we can do y equals 5,600 lowercase e to the 7r power, which we need to type an x. It's just always safer, I feel like, in Desmos to put an x for your variable. And then notice we can't see it on the screen, like we can't see the red function of 8,700. So go to that little wrench and let's put in, let's say 9,000 maybe. See if we can find it. There it is. Okay, and then we just need to find where they touch. And we get 0.063, which gives us the same rate. So in Desmos, you could type y equals 8,700 and y was equal to 5,600 e to the 7x power. And then they touch at 0.063, 8,700, which we don't need that, and the rate was 6.3%. So if you do type some of the ones in your quiz on Desmos, it's nice to show like these steps so I know that you definitely understand what you're doing in Desmos and you don't just give me the answer. So just keep in mind like one of those two things needs to be on your paper. All right, so good luck with quiz 4.